Hi, my name is Renan Lopes. I am a graduate student here at WSU Tri-Cities. I am from Brazil, and you guessed it, as a Brazilian, I love barbecue. I love Brazilian barbecue. For me, is the best. So my research here consists on addressing some of the issues related to livestock industry, and more specifically to methane emissions. So livestock, unfortunately, has a huge carbon footprint, mainly because of these methane emissions. And to understand a bit more about these methane emissions, we need to understand where it comes from. So it comes from a part of cow stomach called the rumen. So the rumen is the first and largest compartment of cow stomach. It is where most of the degradation of feedstock material occurs. And that degradation is through the action of fermentative bacteria and other microorganisms that takes that feedstock and converts and breaks down to volatile fatty acids, or VFAs. And it is these VFAs that actually the animal utilizes and absorbs for production of the products that we're interested in the animal, like milk and meat. So VFA production is very important for farmers, for the productivity, and during this breakdown, this material, other products are also formed, like hydrogen and CO2. And because this whole fermentation process occurs in an anaerobic environment or environment without oxygen, hydrogen plays a central and crucial role in how well these bacteria can break down that feedstock material. So accumulation of hydrogen is very bad. It leads to very inefficiencies in this whole process, and is actually naturally kept low through the action of methanogens. So methanogens, they consume that hydrogen and CO2, but they unfortunately use it for the production of methane. So upon inhibition in the lab, what we've seen is when methanogens are taken out of the picture, we see that accumulation of hydrogen, and the ability of bacteria to break down that feedstock material, it's inhibited. So my research consists in trying to find alternative pathways or alternative microbes that can utilize those same substrates, hydrogen and CO2, but for the formation of more volatile fatty acids, more specifically acetic acid. So we're working with some bacteria that can be found in other anaerobic environments where we see them prevail over methanogenesis. So an interesting one is the kangaroo microbiota. So you'll be able to cultivate some of the bacteria found in kangaroo. Kangaroos actually rely in a very similar process for the energy requirements through VFA production, but with no or very little methane production. So we successfully able to introduce them into rumen cultures in the lab and have improvement on VFA production. So hopefully those will be future tools for the farmers to realize.